Okay, Bismillah ar-Rahman ar-Rahim. Today I'm going to have an overview of software engineering concepts to prepare our students, computer science and engineering students at Yanbu Industrial College for the Jahizia exam at 2026. My name is Fadi Al-Hirsch. I'm a faculty member of computer science at Yanbu Industrial College. So the contents of today's overview, I would take an introduction. I will talk about the software engineering as an overall. Then we will have an overview of all about the processes of software engineering, and then we go to the core steps or processes in the software engineering. So from chapter 3 to chapter 9, we will talk about the processes in details. At the end, we will talk about project management in software engineering. The first chapter, or it's an introductory. We need to understand that there is no universal process for software engineering to develop a software. When we are talking about engineering, it's like making a building. We engineer a building, we have drawings or a blueprint that we design the building, and then after that the contractor will build the building. In software also we have the same. We create a blueprint or we design it, and then we give it to software developers to develop it. So we will look into the software engineering, that we are creating a software product. Okay. So there are fundamental ideas behind the software engineering that is applicable for all software. Number one, that we need processes. Okay, we need several processes. It's not only coding. It's not that you write a code. A project, we need a project, and a project need resources. So it will be employees. There will be timelines, a schedule, a Gantt chart, a team management, a quality management. There are multiple aspects in order to, at the end, to create a software product. So this product, when I say we as a company or a team of software developers or software engineers, we would like to create a product. So this product, we need to sell it, or we need to deliver it to a customer. Um, Secondly, we have the software dependability and security. It's not only we rely on persons. Then we have requirements engineering. We need to understand what are the requirements of the customer. Okay, it's not healthy that the developer create a software independently without understanding what are the customer requirements, similar to an architect. Then the last thing here is the software reuse. It's also a common practice in development that you don't always start from scratch. You build on the others' work. Okay, so what are the attributes of a good software? One, it should be maintainable, and then it should be secured and dependable, the efficient also, and acceptable. So acceptable by the customers. We have the fundamental types of software products. So this customer usually either he requests a generic product, which is software companies usually develop it for a broad market, or most likely, which is a huge market nowadays, that the customer require a customized product, so it is tailored to a specific customer requirements. So an overall, in a nutshell, how can we define software engineering? Software engineering is a discipline concerned with all aspects of software production. So we produce a software. So to produce a software, we have many processes to do. So from early stages of system specifications, we specify what does the customer need, until we reach to the stage where the customer use the system. So the whole process, all of these steps, we are going to cover it in chapters, the coming chapters. So what are the, in order to develop this software, what are the activities that we need to do? There are four fundamentals activities. One is to specify what the system should do. Based on the requirements of the customer. Then we develop it itself, and by development we mean we design it, and then we write the code or program it. It's not as simple as that, because now software is developed dramatically. So there are some softwares that you can only customize and with zero coding. But anyhow, the third thing is to validate, to make sure that the software meets the requirements of the customer, and at the end, after that, the delivery of the software to the customer is using the software. We need to look into the future after the customer receive or accepts the and start using the software requires evolution, so to meet any future changes of the software. um, One aspect we need to look into is the difference between computer science and software engineering. Simply, computer science focus on the theory side, and software engineering is in on the practice, on the how. Okay, it's a more applied side. There are generally, when you develop a software, there are generally some issues related to the development of softwares. One is heterogeneity. So there's a diverse systems and environments. So this is an issue. And then there is the change of the social change and the changes of the business itself. In the future, this business might change, and then they will tell you, okay, we need to develop this software, change that software, or this part of this software. And then we have also another issue about security and trust, and also the challenge of scalability or scale. Scale means when the in with the when you as a software developer or a software company give a customer a software, then this software after some time it will serve more customers, it will, or users. So suppose now we have 1,000 users, the system is running, everything is fine. But what about 5 years from now? What will happen? How many users you will use? Maybe you are going to serve hundreds of millions of users. So this is scalability. So a lot of issues will come during time, and it affect the software, as I mentioned. Now we have 5 different types of software application. Most customers or require different types of applications. Generally, we have different types of softwares. First, now the operating system, we call it system software and its utilities, and then the application softwares like word processor, etc., etc. Also, we have the embedded software, which is the systems embedded or inside the cars or microwaves, etc., or appliances. Web applications, which is very common for you, and the apps, etc. Also, we have the AI softwares. These are the commonly categories of different applications. You in the future might work as a software engineer in a company that is specialized on one or more of those types of softwares. Software engineering fundamentals that apply to all types of software systems. So this is an engineering fundamental. So you have to have, in order to, if you say, okay, I'm an engineer, I'm a software engineer, I would like to build a software product or a software system, then you have to be systematic in your approach. You have to imply or apply quality management. You have to apply the project management and the risk management. So if you lack any of these four understanding concepts, you have to take additional courses beyond your computer science program. If you don't know about the quality of the software or the project management or the risk management generally. Usually in our study programs, we much focus on how to do technically all the uh, requirements to develop a specific software. So your study program usually help you to be a software developer at the end of your study, end of your journey at YIC. But these three, quality and project management and risk management, this is you can do it on your own for a better future career. Uh, Maybe this is uh, the last thing I would like to talk about is that if you practice your future career as a software engineer, so there are code of ethics you need to adhere or you need to be aware of uh, during to work to practice it in the work environment. So this is a set of principles, okay, uh, to conduct your work ethically and professionally. So if you claim to you are a professional, then you have to at least um, make sure you think of the public interest during your work. Don't conflict with that. Also, don't conflict with the client and the employer. They don't affect negatively the relationship between them. You make sure that you make a successful product. Okay, then the judgment and the management, the profession itself, you how you develop your career step by step. How do you work with your colleagues and yourself itself? You manage yourself. So all of these kind of things, you should not have any conflicts with them. You should not create any issues that will affect your reputation at the end. So you need to fulfill all these ethical conducts in in this way. I'm concluding this chapter one. So the chapter one is just overview about what is software engineering, what are the main activities of related to software engineering. Again, I will start with the uh, repeating the same thing in chapter one, the fundamental activities for software engineering. I will repeat it now again because from now on we will go deep onto the details of these processes or activities. So we have specification, development, validation, and evolution. Four of them. So there are the four major activities. So specification, what the system should do. Development, we design and then we implement this design, okay, based on the what we the specification, based on the specification. And then after you implement means you build the system, you create it. Yeah, then you have to validate to make sure is it fulfilling the customer, what the customer wants. And after that, as I said, we have the before the evolution stage or activity. We have three generic process models that are used in software engineering: the waterfall model and the incremental development model, and then the integration configuration model. Also use we call it reuse oriented or component based. Well, anyhow, these three models, it is like a way how you develop a software, because every software has its own characteristics. So maybe you will use this way or this way or this way. We have three ways. This is commonly used in the in practicing in software engineering. So we start up with the first one, the waterfall model, and simply it is like a waterfall from top down. It's like a water going from up to down. Okay. So once you finish this stage, you go to the next stage. You know, go to the next stage, and if you need any feedback, you go back like this. Okay, and anyways. So we take the requirements of the customer and then we design and then we implement and we integrate and then we operate. These are the simple steps to it. So everything is defined, um, already defined. You have a plan to do these kind of things. Uh, so this is a linear or sequential approach. Okay, you must complete before the next one begins. You complete the step, and then you go to the other one. We have a heavy documentation. Everything is well documented, and everything well documented even before you start working. So everything is a plan, already planned. So this is when a software engineer or software company uh, is more likely to use this way of developing a software, the waterfall. So when they use the following systems, embedded systems, like a system inside a car or inside hardware. So before you manufacture the hardware, you already know what software you are going to put inside it. So it is planned previously. Also, some of the critical systems, that is like the security systems or safety system, or some of the systems are very large engineering systems. The other type of way to develop a software, we call it the incremental development. So you have a description of what you want to do, generally an outline. Then you write the specification, you develop it, you make validation. Okay, but the point is, while you do these activities concurrently, the same time you are doing this, you can have an initial version, and then after some time you can modify this version and you have intermediate version, and you repeat again and again. You do specification development validation, specification development validation. Every time you uh, develop the software incrementally until into different iterations, until you find at the end you reach to the final version. So this is more dynamic than the one before, than the waterfall. So you can make an initial version, but the waterfall does not have initial version. With waterfall, directly a final version. So this approach interleaves the activities, and then it develop a series of continuous increments. Okay, at the end you have the final. So it have an iterative approach, and you need the user feedback always to do this. So what type of software usually is good? This is somehow an agile way or a flexible way. So web-based systems you can use it. Business systems, small and medium-sized systems, more and more types of systems can be used in this way of development. The third way is integration and configuration, which is heavily rely on object-oriented or reusing the software. So you understand the requirements, then you try to discover what types of softwares you need to build to use it or to reuse it. Okay, and then you can have the evaluation. Again, you refine the requirements, and after that you start the configuring the application system, adapting, adding more components, and then at the end you integrate everything in one system. Okay, so if you have any issues, problems, you can go back. For example, from here you can go back here, and then you have to develop requirements again. As you see, after you integrate the system here, it's very difficult also to come back here. Okay, there's no arrow. So this is one of the deficiencies in this integration and configuration. But usually companies might not follow this 100%. It might differ than the reality. So this is only a way, a generic way. All these ways, the three ways, the waterfall, the incremental, and the integration, all these ways to software development, they are generic. يعني in real life, maybe you go in any company, work in any company, you might find them using one or more of them, or they are mixing these ways or these methodologies. Actually, some companies, they have their own company methodologies. Like SAP company, they have SAP ASAP methodology for software development. IBM, they have their own methodology. Oracle, they have their own methodology. Microsoft, etc., etc., etc. Right. The component based or reuse based, it focus on reusing existing software components. This is the most point, which is which will have the lower cost, okay, than the other ways of or methodologies of software development. What type of system we can use it? Business systems, web-based systems, also product lines, large-scale systems, and complex systems such as ERP systems. As ERP system like SAP, as I said, or else. Okay. So now we will go after understanding the for the um, methodologies, different methodologies, and we understood the activities of the how to do the software, how to design a software, or how to engineer a software. It's not only designing, also so how to engineer a software. There are four steps or four phases. We will now in chapter 4 we will start in details talking about the first the first process or first activity or first phase of software development, that is the requirements engineering. So requirements engineering needs, first we need to you need to have a larger understanding or a wider understanding that you are not talking about the customer or the end user. No, you have something called stakeholders, and stakeholders, anyone who is affected by the system, and that will include a development team that maybe you are a member of in your company. We have a project manager, requirements analyst, software engineer, developer, or test engineer. Sometimes the software engineer called software designer. Sometimes they call it system architect. There are many names in the market. Also, in the stakeholders at the side of the customer himself or the client, that the company that needs the software, you will have the manager of some sort, or maybe the CEO sometimes, or the end, and sometimes some engineers, some business analysts, contractors, power users, end users, and some support staff also. They might interact, all of them. They will be involved in developing a software product at the end. So this is a small processes of how all these kind of things happens. Um, in requirements engineering, there are principal stages in the engineering process, requirements engineering process. One is elicitation, then the analysis, and then the specifications. Uh, what at the end, what do I create as a software developer or software engineer? Sorry, as a software engineer, you might at the end, after you make elicitation, analysis, specification, you create a requirements document. You have a document that describe all what the customer need. Then these requirements you give it to the designing team. The designing team will design it, and then after that, the design team, when they finish design, they give it to the people who create the system or the developers or the programmers. So we have sorry, there is one bit here, requirements and validation. We validate the specifications. So we elicitate, we analyze, we specify, and then we validate. We check it that it is valid or not. User requirements and system requirements. So if you are working with the team who make the requirements document, so first you need to understand the user requirements, which is statements. Maybe you can put some diagrams with these notch statements, okay, and you describe, okay, what the customer need. Okay, so this is in his own language, and after that you break it down in more details in a technical way. So this is what we call it the system requirements. So the user requirements is written in the language of the client, where the system requirements are statements written in the language of a technical team, which is usually you as a software engineering will and your team will work on it. So you will define more details than the descriptions of the user. So you can think of the functions of the system, the services of the system, how the system will operate, if there are constraints or not. So so these kind of System requirements you usually defined into functional or non-functional. So a functional that is mandatory, a functional requirement is a statement that describe and it is mandatory to fulfill the customer requirement. The non-functional, this additional things around that will, if you ignore it, you might not be able to do the functional requirements. So these are the team that might be working on creating the user requirements, and these are the people or team that might work on the system requirements. It's not 100% but it is like an example you can think of. So for example, a user requirement define and say, for example, that this is some sort of a manager or whatever from the client. He say, I want this system to generate reports and show the cost. Then you at the company, software company, you take this statement, okay, and then you break it down into more details, okay. So in these details, this is the system requirements. So you will specify more details about it. So this is what these details. So in these details, you can have more talking about authorized users. You can talk about specific units and details, standards in the company. You can talk about specific timings and days, any day of the month. It's not generic, it's very specific. You should be very specific, because if the company you are developing the software for, if they agree on this, okay, then the designers will design and then the developers will develop the system. A lot of work will be, and at the end, if the client is happy, he will pay you money. So you have to be critical. You have to be very specific at this. طيب. Non-functional requirements is varies to a lot of variations. So you can think of non-functional requirements. It can be anything of in this tree or and more. So for example, I will write, for example, if maybe there is a space requirement. Space, maybe this space is not enough to do this kind of a function. For example, if you want to have store some products inside an inventory. So if the space of the inventory is limited to a specific limit, that you should not store more than 100 items in this room, in this warehouse, or in this inventory. So this is a constraint. Okay, so this is non-functional requirements because of the standards of the company. Sometimes it's not the company that make these standards. Maybe the government is doing this kind of standards. So maybe the environmental requirements, maybe something legal, something ethical, something is about security. So many things you can consider in non-functional requirements. طيب. Then now I will just talk about the elicitation, eliciting or taking the information from the stakeholders, collecting the information, extracting the information. Sometimes it's difficult because maybe the stakeholders don't know exactly what they really want, and this you get stuck in these situations. The stakeholders may express requirements in their own terms, in their own language. It's not useful for you as a software engineer how to make a system out of their statements, etc. There are several difficulties, but also there are techniques for elicitation. Number one, you can make interviews, or maybe you can design use cases, and we will see them later, inshallah. Okay. Or maybe you have observing closely the ethnography. You come and sit next to someone in their environment, some user. You sit next to him and you observe how he's doing his job. Or maybe you can create some scenarios, or maybe you can create a prototype, or some observing some users interacting with the system, uh, or making questionnaires, or making workshops, or brainstorming with sessions. All of them are techniques you can use it to elicitate information from the stakeholders. Um, This is an example of a use case. So we said one of the techniques is use case. So a use case is a scenario-based techniques. It is designed using a standard called UML, Universal Modeling Language. Usually you have an introduction about Universal Modeling Language in CS 102 in Java. Java programming, or object-oriented programming using Java during your study program. So this is a simple design, okay, that talks about what does the medical receptionist do, what is his role, what are the actions, the verbs he uses. So we make a simple stick man here, some design. We write his name as a position, yani what his position, what his job is. And then here we start using verbs. What does it register? So the medical receptionist register patient. What else he can do? He unregister the patient. What else? He view the patient info. What else? He transferred data. What else? He contact patient. So this is a simple example of a receptionist inside a medical clinic, and those are the actions he do during his doing his job. Okay, how we uh, got this information? So you, as a software engineer, maybe you used one of the techniques before. For example, you had an observation. You sat next to him and you observed his job, and you took notes. You were writing notes. So you wrote, okay, he did register, he unregistered, he view, he transferred. Or maybe there is in the team, there's a business analyst from the company. You said to him and he explained it for you. And maybe he gave you all these details already in written. Okay. So it depends. We have uh, the next chapter. Okay, after collecting the requirements of the client or the customer from all stakeholders, and we wrote the user requirements and the system requirements, and we wrote under the system requirements which requirements are functional, which are not functional, and everything we wrote it. We did it and we saved it inside the requirements document. After that, we give this document to the software um, developers, or software architects, or software designers, or simply a software engineer. This engineer, his job is to create design. He design. So in your book, we are using the universal modeling language. So every box has a specific meaning here. So this is to define a component. So this is part of the system, and this is a package. Okay, it's also represent a part of the system, either as components or packages. We have the object. As you remember, in object oriented, anything that exists is an object. An object. Anything that exists is an object. So the system can interact with. And then we have this sticky man here, is an actor. So anything out that interact with the system outside the system, it need to interact with the system. We call it an actor. And we have the use case. This is an ellipse to define a use case. Inside this ellipse, we write verbs, as I said before. And we have this design, this shape to define an activity. Okay, to define an activity. We saw this example before. This is a use case, okay, that show the medical receptionist interaction. Now, if we have multiple actors, how they interact, because sometimes this viewing the personal information is done by the manager or a medical receptionist. So we put it like this. Maybe the nurse would like to edit the record, or the doctor might edit the record. So you can put more and more actors in your use case design. Also, we have the classes design. This is another UML called a class diagram. And this class, you define what are the objects inside the system. So this is an example of a clinic. So inside the clinic, what are the objects? A patient is an object, a consultation is an object, consultant is an object, a condition is an object, etc., 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 and you define the relationships between them. If you take one of them, for example, the consultation, here you can put the details of it. And this is, if you remember, this is a class diagram in Java and Object-Oriented Programming, CS102, if you remember. You write here in this area here, okay, these are the data we would like to save and interact with. And here are the actions, okay? Here are the actions or the methods that you know. طيب. We can also طيب, when we design the system, we can think about the external perspective, okay, with the environment يعني. Okay, design, you have to design something that describe the context or the environment of the system, or you have a design to show the interaction, okay, or you have a structure perspective or behavioral perspective. Every one of these four has a specific UML design. طيب. For example, if you want to describe okay, let me show you. Okay, these are the essentials. These are the UML diagrams we were going to go through this chapter. The first one is the class diagram, and it is a static structure of the system. The activity diagram represent workflow step by step. The use case show the interaction between actors. Sequence diagram has an interaction in a particular sequence. A state diagram is more dynamic behavior. Every one of them has a specific يعني, use these designs. Now we will see these designs in detail. So now the first one is the context model. I want to design something that show the entire system, the whole system in simple boxes. So I will say, for example, I want to design this system, and this system has multiple components or subsystems. Okay, so I write everyone, all these boxes are the subcomponents of the system. We call this a context diagram. Also, this is another way to see the system in a يعني organization way. So we can say we have the يعني a physical architecture of the system. So we can say this is a server. We can see a server, and this server interact with the network, and then we have clients. So it will show you the client server architecture. Not only this, it will show you also that we have a database. Right? So this is more like technical way to see the system. So this one you can give this design to people who are non-technical. You can go sit with the client and tell them, okay, we will design for you a system that will do admission, we will do prescription, we do that, we do this. Okay, but this design, it is an overview of the system also, but this one, but it's more like technical way of defining. Okay, طيب. Also, we have packages. We design packages. For example, we can write that the system is, we can define it in 3 packages. Package 1, package 2, package 3. Every package, it will create the whole system. Also, we have layers. This is a more like architecture design. We can like, this is one combo. This is not only one component, it has several things, two things, and inside here we have 1, 2, 3 things. Here we have many things so every box represent services. Okay, so I can say that my system, for example, this is an I learning system or online learning system. Okay, it has a utility services. What are the services? He said, okay, authentication, logging, interfacing. Like what else? He has application services that do email, messaging, video, conferencing, etc. Then we have configuration services, group management application, identity management, etc. And then we have browser-based interface and the app at the top. This is at the top. So the other, this is layer, multiple layers on up top of each other. And at the end, this is a design that will show us the system overall. So which one of these designs we need to do in the real life? So it depends. I don't know. It depends on the project. So you have to understand the project and then sit with your team and decide which one of these is best to describe the system. طيب. These are the example of an activity diagram that will show the workflow of the system. The activity is like you have an object and then a verb. So this blood sugar sensor is an object. And after that, what will happen? There is a verb, an action that should do. Okay, so this is the arrow that show the steps. So we start from here, you go and you got the blood sugar sensor, get sensor value. So your software will get the sensor value from the blood sugar sensor. And then after that, the value is sent to the sensor data here. And then from sensor data, we go and compute the sugar level, etc., etc., etc. So as you see, it's all about objects and actions. So we call this an activity diagram. Right? We have something called a sequence diagram, which is more complex, that will show you more about the diagram, how it is in the interaction. So we have the objects here, we have the actor here, medical receptionist, and then you have to specify more and more about the verbs. Verbs, view, report, authorize, and then maybe you return back, and then you have options. This is option number one, and we have another option here, two options. We may get after authorization, after you authorize the user, either you authorization is okay or fail. So you have two options, alternatives. ALT stand for alternatives. Okay, so this is called a sequence diagram. طيب. Uh, this is the state diagram, which is more and more complex system. This one is showing the state diagram will show you more about the interaction and the behavior of the system. So it's more complex. It will show you, for example, that if the power is set to 300 here, then do this. But also you have another option. Power if power is up to 600. Okay, so it will give you more options. Like maybe you can close the door, maybe the door is open, what you will do in this case and that case. Okay, maybe you have to start, or maybe you can cancel. Okay, so you have many options, you define it here to explain in details the behavior of the system. We don't have time to explain it thoroughly, you can check it over the net. طيب, the next chapter we have is chapter that is talking about the architectural design. Now in architectural design, um, uh, we have the advantage of explicitly designing and documenting a software architecture, which is good for the stakeholder communication, also the system analysis, and also for reuse or evolution support. When you have a system architecture or software architecture is very useful for these four things. The two way in which architecture model of system may be used as a way to facilitate discussion or as a blueprint. A blueprint يعني for implementation, like the in building or building something. طيب, fundamental questions that should be addressed when you make a design, an architectural design. Is there a generic application architecture? How will the system be distributed across hardware? What architecture patterns, if available? What components will be used? How will non-functional requirements be addressed? طيب, all of kind things. So we have يعني in order to we have the to in order to see the system in multiple views, okay, because there are many stakeholders. We have people from the company, they are not the same, because the CEO, for example, or the board members of the company, they might not like to go into technical details about the system, but maybe they have in their company some engineers and some technical staff. They would like to see the details. So some of them are they know they are into the development and software and IT, but some of them are no, they have zero IT background. So this is why we have this different views of the system, views of the system. This is the fundamental idea. So Krachen's 4+1 model. So we have something called the logical view. It is important because it shows the abstractions. It's just simple core information, very less words, okay? It may be classes, maybe some relationships. So this is a logical view that will show you. The other one is the process view, which will show when there is a process view, then you have to go to step by step. So show the behavior or the concurrency or the interactions or all together. And then we have the development view, where you have to module or organize your software. So you have the physical view, as I mentioned before. We have, for example, the network or the server or etc. And then at the end we have the +1 scenarios. And in this scenario, we can use this scenario in any of these views. You can build a scenario in any of these views, so that in any phase of the software development, scenarios is a very useful tool to make the teams work together effectively. The teams, I mean, either the software team, software development team, or the project team, or and the team from the client or the customer. طيب. What is an architectural pattern? It's a reusable solution to a common design problem, providing a structured approach to organizing components and their interactions. So it is a solution to a common design problem, something that is frequently happening, problem that frequently happening. So you have a structured approach to organize these components. So for example, this is MVC or the client server. طيب. I will stop at this stage. Maybe you can go and check the rest of this data, the rest of information about this chapter. Now I will go to the next one about the chapter 8 about the testing. So once we develop the system, we work on and implement the design the system, we implement the system, we do the testing. So during the testing, we have to understand that in testing we have something called validation and verification. In verification, we ensure the software meets the requirements. In validation, we ensure the software meets the user needs and expectation. Okay. So this is two different aspects. The simply we can say in verification, are we building the product right? Yani we are building every day, every week, every hour. We are working on building. During building, are we building right, correctly? This is verification. So we verify during the building. Validation, no. Are we building the right product? So will the user will be happy when we finish building? Is he going to be happy? So this is validation. So in validation, usually the software is ready, either pre-release, before we release it, before we do it, we just do some testing, etc. So but the verification, no, verification is during building. Okay. So usually during validation and verification, we search about defects, errors, anomalies, okay, whatever any problems in these during the so the defects is an imperfection of the software product. Okay, so maybe a coding mistake or something. An error is a human action that produce incorrect result. Okay, for example, misunderstanding the requirements, okay, incorrect logic. The anomaly is something not correct يعني behavior, something unusual. طيب, a condition that deviates from the expected behavior of the system. Unexpected system crashes, for example. Okay. طيب, there are three principal stages for testing, especially for a commercial software. First, we do a unit testing, which is the simple components of the code. يعني programming code. If you write code in C or Java, you can understand. This is a simple unit, a block of code, يعني between braces, for example. So interaction testing, then you have multiple functions or that interact between each other. Okay, and then after you finish unit test, creating the units of the program, finished the integration between these units, then you can make a system thing where the complete system you can test. So this is type of testing. طيب. We have the white takers guidelines for defect testing. So that focus on the common defects, test defects that frequently occur, use historical data, and test boundaries. So this is also best practices in software engineering. There are three important classes of interface errors. Sometimes the parameter is error, or the timing error, or the data error. طيب. So these are يعني one of the best practices you can check during the coding if you review your code. طيب. Most important benefits why we do test driven development, because we want to improve the code quality, reduce debugging time, or better design. We have something called stress testing. Why it is useful? Because we put the software under extreme conditions to ensure stability. So is it the software stable under pressure, under extreme conditions? So this is why we search for bottlenecks and ensure that it can handle high loads. So we call this stress testing. So there are three types of user testing. If you want the user to test the system, so first, after you as a software team, you had finished a software, for example, you developed a software, and then you did not give it to the customer yet. You finished development, and the software is still in your company and still inside the software development company. Okay, so if the internal stuff, your team made the test, so we call it alpha test. Okay, and if the test is done by external users before release, yani before you give the software to the client, we call it beta testing. And then the last thing is the acceptance testing. Then you bring the real customer to validate the system. The real customer employees, they come, you give them the system, they use the system really, and so this is called the acceptance testing. This is why they pay you money. Okay. طيب. Chapter 9, or the software evolution, which is the last step in software activities. As we said, we have 4 activities in software. 4 activities. The activity number 1 is software requirements engineering. The second one is the after requirements we have the design, and in design we design the design, and the third one is the implementation. We implement the system, and then we have the testing, and now we are in the evolution, something that beyond simply testing. Okay, the software is used in the company. After some years, maybe the company will tell you, okay, do this, do that, make this change or that. So we have to work on software evolution is important because during time, uh, does the software or the software continue to meet the changing user requirements? Does it continue to do that? So we have to check it after some time. So this is we modify the system, we update the system, we make, like for example, we make a version 2, version 3, version 4. Okay, or sometime in Windows, Microsoft Windows, you say, okay, there's a system update after some time. It's a cumulative update or upgrade or something. طيب. The stages in so in evolution process, okay, we have the initial development where you have the initial version of the software, then make the evolution, يعني making changes as new features required, then the servicing where the minor updates are you needed, then phase out, gradually reducing support and updates, close down, ending support and retiring the software. All of these kind of stages might happen to any software. So you start with an initial version. Maybe during time you need to make evolutions. Then it is working very fine, doing their service. Some minor updates is required only. Then after some time, this software may be not needed. So you have a phase out. So gradually reduce support and update. And then maybe you can shut down this software and never use it or never sell it. So these are of the things you have. Why might it sometimes be necessary to bypass normal change management systems? Because these urgent changes might be necessary to address critical security vulnerabilities, fix major bugs, disrupt operation, or comply with urgent regularity requirements. Maybe the government tell you do this kind of things. So you have to يعني do this kind of and then this will also lead us to something called the legacy system. The legacy system is old systems, been there for tens of years. So you have some the system have a hardware, a software, data, processes, documentation. This is very old system, so it's expensive and maybe make a lot of problems. So what can you do with this legacy system, this old system? The legacy system, maybe you can scrap it, خلاص, put it in the trash, or you maintain it, or you transform it. So this is the three decisions you have to do, but you have to assess, make a realistic assessment before you decide. طيب, we have also in maintenance, if you decide to maintain a system, we have corrective maintenance. You also make repair or fix the bugs. That's it. We have adaptive maintenance where you have a new change in the environment and you have to adapt to a new platform and something new in the inside the environment. This is adaptive. And then we have perfective maintenance. The system is working fine, but we need something additional feature. So we call it perfective maintenance. Okay, these are the types of maintenance. Bye. Last thing we have now today is about the chapter 10, software project management. In software project management, software engineering is about building a software, a product with that which include technical and non-technical processes. Software life cycle. This is based on the international standard, 2017 ISO, IEC, and IEEE number 1227. This is a standardized process. It's not something that an individual created. These are scientists and professionals have gathered together to create this kind of a standard. So they develop list of what is all necessary to make and build a successful software product. So starting from making an agreement, acquisition and supply, which is non-technical with the client, then you enable your organization that we are going to build a new software. So you define all the necessary requirements inside. And then after that, you have the team who are going to work on the project. So you plan, project plan, and you define the assessments. You decide the work on the decisions and the risk managements. What are the risks? Any information management required, and configurations, the quality assurance aspects and measurements. So you define everything here. Okay, and then after that, you work on the technical side, which are the four steps we today discussed in details. If you recall, we talked about specification, development, here engineering, requirements engineering, which is specification, and the development. Under development, we have the design and implementation, and in validation and evolution and maintenance. All of this we described today. These, all of them, they are considered according to the standards. They are called technical development, implementation, and support processes. So you are a software engineer. Your mind is about all of these kind of things. You work with teams in specific projects with these details. But the actual reality in your real life, you have many things happen before step number 4 here. You have these things happening, all of these kind of things. There are many things inside your software company that need to be decided and specified before you start working. So educate yourself on these kind of things, and these are the pages in your textbook that might help you to understand this in detail if you wish. It is recommended to understand it. So what is a software project management overview? What is a software project management? It is to ensure projects meet the budget, the schedule, and the goals. So the customer will say, I need 1, 2, 3. These are the goals. But we have to put a schedule. We finish this software in 1 month or 6 months or 12 months. And what is the budget? You have to define the budget. So this is are all aspects important in software project management. So software project success criteria: on-time delivery, within the budget, meeting customer needs, and maintain an effective team. So software, we have management, we have challenging because the software is intangible. The projects are often unique. Not every project is similar than the other, and then the processes differ across organizations. So these are some of the challenges. So what are the key activities, key management activities during project management? We have the project planning, then the risk management, people management, and reporting, and then proposal writing. So you should have the ability to write the proposal at the end of the last activity. Last thing I would like to talk about the two things about the types of risks. We have project risk that affect the schedule and resources. Product risk affects software quality and performance. Business risks that affect the organization itself. So these kind of things, examples of project, product, and business risk. So these are examples. So this is a simple example. If we have a staff turnover, staff are resigning, exiting the project, it will affect the project. So this is a risk. We have management change, so it might affect the project. Okay. So for example, here we have requirements change. If the client says, I want to change my requirements, so this is a change on the project and it affects the product itself, right? Also, there are some technology change, for example, at the business side, right? So all of these kind of risks you can find during you may find during the development of any software. Finally, here I will talk about the project plans. In order to create a plan driven development project, we have to put the resources necessary for this project. We have to make a work breakdown and a schedule to make this work. So the plan sections, what you will define specifically in the project plan document. One is an introduction, then project organization, risk analysis, the hardware and the software resources, the work breakdown, and the project schedule and monitoring and reporting mechanisms. So all of these kind of things you put all together. I would just give one example on a project schedule. So for example, here you have just a simple, for example, task 1, task 2, task 3, etc. And here the person, how many days he will do it. For example, task 1, this person will do it in 15 days. Task 2, he will finish it in 8 days. Task 3 in 20 days, etc. So effort and duration. How much effort and how much duration, and is there any dependencies? Okay, we write this dependency. For example, there is a M1 and T1. There are some dependencies between them. Sorry, T3, T3 here. There is a dependency with T1. Okay, this one. Okay. T5, there is a dependency with T2 and T4. Okay. T5 has dependency with T4, this one, and T5, this one. So you make a simple table, but sometimes it's not easy to read the table. So what is the best way? The best way is to make a schedule for your project using Gantt chart. This is a Gantt chart, a sample Gantt chart, and it will show you the dependencies for these tasks. For example, the employee will work from here to here, and then in the same time, there's another task done from here to here. This is happened in week 0, the same time. Okay. In week 2, task 1 will be finished. خلاص. Task 2 not finished in week 2. We have this week. But at week 2 also we have T3 will start. Okay. Task 1, task 2, task 4 also, all of them will start in this week 0. Are they done with the same employee? Maybe, but most likely you will use different persons with this. Okay, but anyhow, you have, for example, task 3 here. Task 3, you have this line here to task 5 and task 6. So you have to finish task 5 and 6 in order to finish task 3. Task 8. Task 8, as you see, once you work on it at this week 5, you have to start on task 9, and then task 10, and then task 11, then task 12. So when they finish all, then you have finished your product. So this is an example of a plan for a project. I hope this overview is helpful. I hope this you find this overview helpful for your Jahizia exam preparation. Thank you for your time. This is Fadi Al-Hirsch from Computer Science Engineering Department, Yamba Industrial College. Best wishes for all of you. جزاكم الخير. السلام عليكم ورحمة الله وبركاته.